Now this is the Johnson Viking Challenger. It puts out a lot more power than I thought it would, as you will see when we tune it up with the light bulb. It's rather amazing actually. Uh, the input power, which is how they measured power back in the 60s and the 50s and before that, is rated at 120 watts CW, which basically should give you about 70 watts output on CW. And the phone output is rated at 70 watts input, which should give you about 45 watts on phone. I have a crystal in there right now for 75 meters or 80 meters at around 3.74, I believe it is. So we're going to see how it works. We'll tune it up and see how everything goes. So I'll put it in. The first thing they want to do is get about 2.5 mils of grid current. So I'm going to put it in the tune position, and we adjust these two controls to do that. Okay, and that's about right. Let's see, we'll adjust the driver up there. That goes way up, but let's bring it down a little bit here. We need to bring it down, that's too much. So we'll do about, actually they said 5 mils, I'm sorry. About 5 mils of grid current. Okay, so we have our 5 mils of grid current, and now we're going to tune it up. Again, we're on 80 meters. Okay, we are in the plate position, and as you can see, that bulb is already starting to light up, and we have very little current going into it. So we're going to increase the current. We're going to increase the loading. Let's do that there. Okay, and we dip the final again, and we increase the loading a little more. I hope I'm not going to blow that bulb, but they want about 200 mils of grid current, and that thing is really putting out. Okay, we got about 200 mils of grid current there. That's enough. I don't want to blow the finals on this thing. Wow, that does pretty damn well. Now I'm going to put it in the phone position, and we're going to see if we have any output in the phone position. And I have it has a push to talk in here, and I have the push to talk kind of shorted out, so I don't have a push to talk mic, so I have it shorted out. So when we go into the phone position, that's what we're going to get. So here we are in the phone position. Hello, 1 2 3 4 5 4 3 2 1. 1 2 3 4 5 4 3 2 1. And I'm going to let you see it on a scope. Okay, we're going to take a look at the modulation on the scope and to see how that looks. I'm only going to do it on this one band, and we'll see how that looks. So let's put it in the phone position. Hello, 1 2 3 4 5 4 3 2 1. Hello, 1 2 3 4 5 4 3 2 1. 1 2 3 4 5 4 3 2 1. Hello, test. 1 2 3 4 5 4 3 2 1. You can see I think it's modulating more than 100%. So I'll step away back from the mic. You see a little bit of feedback on there, but it obviously does modulate. Okay, let's try it on 40 meters. This is set up for 40 meters. I have a crystal in there of 7159, around 71, around 71, about 7160, and we'll see how that goes. So let's put it in the tune position. This goes over to grid, and we got plenty of grid current. I want to point out before I forget, if you're using it on push to talk, when the mic, there's a lot of voltage on that push to talk relay. I don't know how much it is, but I got a pretty good bite out of it when I put my finger on the wrong wire. All right, so we we want to adjust that for about 5 mils, which is pretty much where it is. There we go. Okay, and then we're going to put it over. We'll put it in the standby position and throw this over at the plate, and we'll tune it up. Hopefully, haven't tried it on 40 meters yet. Normally, when I'm doing a video, I try it ahead of time, so hopefully it won't blow up. But here we go on. We'll put it on the CW position, and we got a little bit of power out. We'll dip the final, and it looks like it's pretty much dipped over there as it is. Bring the power up here a little bit. I see the bulb lighting a little bit. We re-dip the final. We'll bring this up a little bit more. Re-dip the final. Okay, and bring it up a little more. And we re-dip the final. And we're only showing about 120 mils of grid current. And there we are. There we are. We are really up there. About 150 mils. I could probably get more out of it. There we are, a little bit more. That's about a maximum power there on. Actually, it's about 150 mils. I could probably do more. But I'm not in the habit of wanting to blow things up. So I'm going to leave it at that. That bulb looked awfully bright. To me, I don't know what it looks like to you. And this thing is pegged at 100 watts, but that meter does not read accurately. Okay, we're going to try it on 20 meters. Let's see, let me make sure. 80, 40, 20. Okay, 80, 40, 20. You can see that meter sure likes to bounce around a lot. They should have bought a meter that had a little bit of better dampening on it. So we're about 5 mils of grid current, and we're going to put it in the CW position. I need to back this off, the loading. I'll back that off. Back the loading off, and we're going to put it in. This goes into the plate position, and we're going to put it in the CW position and see what we get. Okay. Okay. There we are. There's our dip right there. Okay, let's increase the power here. Okay. Still not much coming up. There we go. Check our dip here and bring it up a little further. Okay, and we'll bring it up a little further. There we go. Okay, and we're using a multiplication crystal. I don't know how well these crystals work on multiplication, but that's about 120 mils, so there's not a lot of power there. There we go, and we'll just, there we go. So it looks like it's about 150 mils of grid current there. This is peaking up, but I don't know exactly how much that peaks up. So that's what the crystal doubled on 20 meters. Okay, here we are on 15 meters. Let me check that, make sure it's the 80, 40, 20, 15. Okay, and there's our grid current at about 5 mils. Put this over the plate and see how we do on the CW position. Okay, got a lot of grid current. There we go. Okay, there we are. Okay, that's minimized. We're going to increase the loading, and we'll re-dip it. Okay, increase the loading a little more. I don't think we get a very good match with a light bulb here. This is indicating more than 100 watts, but we're only getting about 100 mils of grid current. Okay, here we are on 10 meters. Let's see, let me put it in standby for a second. This scale is, let's see, that's 6, so this has got to be 10. Put it in the CW position. We'll dip the final here. Wow, we get quite a bit of juice out of there. Okay. Wow, that's That's really bright on 10. That's a lot on 10 meters. It's only showing about 150 mils, and I don't really want to increase it anymore. I don't want to blow out the bulb. So that's about 150 mils of grid current on 10 meters. Not grid. Wrong position. Let's put that again. In the plate position, it's about 200. It is about full power here. Okay, so that's about 210 mils of plate current. Plate current. Let's get that straight. Okay, so there we are. Okay, I have no idea whether this is going to work on 6 meters, but I'm going to check. I'm going to multiply the crystal frequency and see what happens. And I'm going to take the lazy way of multiplying the crystal frequency by checking Google. So we'll watch this, see what happens here. What is 7 times 7,159?
The answer is 50,113.
Okay, so I guess the frequency will be about 50.113, so we'll give that a try. Okay, I did try to set it up. I multiplied the crystal frequency out as indicated on Google, and 50,133. I don't know if you can see that. And let's put it in the tune position and see if we find it. Okay, now they only want 2.5 mils of grid current on this frequency, so we're going to bring that down a little bit. Okay, so there we go. We'll bring that down a little bit. I don't know if we're going to get anything on output on the 6 meters, but let's give it a shot. And they only want 150 mils of plate current as well on 6 meters instead of 210 mils of plate current. So we'll give that a try, see how that works. Let's throw this in the CCW position. And there we go. That's too much. Okay, we got 200 mils of grid current. Okay, we have 200 mils of grid current. That meter would stay stable, which is too much. Let me bring it down. Alright, so it's too much. So I just want you to understand it is too much. But we're using a light bulb for an antenna, which may not match up very easily. So we'll just kind of leave it there. Okay. So the Viking Challenger sounds like an interesting rig to me.